So let us see alternator. It is similar to very DC machine that field is moving in alternator and conductors are stationary. It has a shaft, an alternator. So let us draw rotor part first, and then I told you that the field is a part of rotor. So you will have a field system here. Let us draw 4-pole system. So something like that. Now this becomes my rotor part, and this is outer diameter. So this is your shaft, this is your pole, and this is called spider. Your field winding is here. So this is your field winding. And also we have damping rods or damping winding. So that is, we can put some holes here. So this is for damping or damper winding purpose. So what they will give? They will give shaft radius or diameter. They will give rotor outer diameter, and they will tell whether 4-pole or 8-pole or 10-pole, and some dimensions about field winding. Now this is rotor part of a alternator. So it consists of shaft, then we have poles, the spider, and field winding. Now let us see the dimensions. If you know the width of the pole and if you know the pole arc, you can draw the main pole. Now let us see stator part. We have a stator So as I told you that stator has slots where conductors will be there, and it will have three phase windings. So we have slots. So these are the slots. So this is the outer diameter of a stator, and these are slots. Now when you combine these two, this rotor will go inside this stator, and that becomes a complete alternator end view. So in stator, what are the things we should know? We should know the outer diameter of the stator, and we should know the slot dimensions. Now we have different types of slots, and we'll see one by one. So this is the basic diagram of alternator. So let us take some reference. Now stamping OD, outer diameter. OD means, please write down, OD is outer diameter. OD means outer diameter. So diameter is 405 mm, outer diameter. So I'll draw outer diameter. This is my first one, stamping OD. Outer diameter is 405. So I'll mention here, this is OD 405 mm. Now it is given inner diameter. Inner diameter is 240 mm. So some reference I'll draw. And here my slot dimensions will also come. And there is a housing OD. Housing OD means the cover of the alternator. So I'll complete that part first. We have housing OD at 455 mm. So this is housing OD, and the dimension of this is 455 mm. So I'll write this is housing. Now we have a slot. Number of slots are 48, and core length is given. Length it is not required here. Let us directly go to dimensions of slots. Now it says that the slot dimension is shape is trapezoidal. So shape is trapezoidal. So I'll draw one slot here. So let us take one trapezoidal. Height is 44.3. So this height is 44.3. This height is 44.3. Next, lip height. This part is called lip. This is called lip. This lip height is given. This is 4 mm. This is called lip. This part is called lip. Next, slot opening. This part is 3 mm. This part is 3 mm. Slot width at the top. At the top is this. So this is 16. Slot width at the top 16 mm. And slot width at bottom over the lips is 10.76 mm. So this distance is 10.76. So what we can do is we can change it like this. So your diagram will be like this. So this is 16 and this will be 10 and opening will be 3. Now let us draw 48 number of slots. So what we can do is we can draw the slot outside this housing, and then we can put it in the sketch. We can cut and copy and paste it here. So my slot would be looking like this. This is my one slot. Now you make a pole array, make a polar array, and number of slot is 48. So it goes like this. Again, it goes like this. So this becomes slot, and this is your housing. So this is your slot, and you complete this part. So again, this is your slot, and now you make your shaft, and these dimensions are not given. So roughly you can complete this part. So this is my rotor part, and this is shaft, and we have a dovetail joint. So this part is dovetail, so that my poles, it is strongly, it is holding, and we have a damper holes. So these can be assumed accordingly. So this completes your sketch for an alternator, and this is 50 marks for one question. So they have given shaft diameter 7.6 centimeter. So let us start with the shaft diameter 7.6 centimeter. So this is a shaft with a diameter of 7.6 centimeter. Now, next diameter of rotor is given. So 46 centimeter. So let us draw a reference circle with 46 centimeter dia, and it has number of poles 10. We have 10 poles. Height of the pole is given 7.6 centimeter. So what we can do here is, from here I can take a height of 7.6 centimeter and draw a pole. Width of the pole is not given, only height of the pole is given. So I'll draw a pole like this, and I'll copy 10 times because there are 10 poles. So please remember, the diameter of rotor is given 46. So the pole arc should not cross 46 centimeter. So we will have 5 here and 5 here, 10. So we have 10 poles. Since it is asking half sectional, so we are doing only half part, and this is my shaft. So what you can do is draw one pole, and you can make a polar array of 10. So use a polar array and make 10. If you want, you can show field winding also. This is field winding. So only height is given 7.6 centimeter. Now outer diameter of stator is given 76 centimeter. So I'll draw a circle having a diameter of 76 centimeter, and there is no dimension of slot, and inner diameter of state is also not given. So we can assume it, and we can draw the slots. So what we can do is, let us assume some inner diameter. Diameter shaft is given, done. The outer frame, it is given. Rotor, number of poles, height of pole is given over, and hydro diameter. So let us assume now, and let us make some slots since it is not given. So what we can do, we can just complete this diagram with some slots. So it is asking only half sectional end view. So we can draw and now the frame diameter is also given. So that is 92 centimeter. It is given. So this is your shaft with the diameter of 7.6 centimeter. Then this is your rotor, and the diameter is 46 centimeter. This is your frame, and it has a diameter of 92 centimeter. Height of pole is mentioned, so I'll take this as a reference. So this height is 7.6 centimeter. This is height of pole. So I'll write here pole height. Height of the pole is given, and this is stator outer diameter, that is given as diameter is 76, and this is our base. And number of poles are 10. So half section view, we are showing only 5. So this is what is mentioned in the question. And now let us draw the front view. So what we can do is we can take the extensions. So length of the stator is given. Length of the stator is given. Let us make this as a reference line. 16 centimeter. So first shaft comes into picture. Now the stator length is 16 centimeter. So take 8 centimeter this side, 8 centimeter this side, and we can draw the stator. So stator, this is my pole. This is my stator. And so this gives you the front view of alternator, and this is your end view of alternator.